Hello everyone, welcome to episode 2, or lesson 2, of organic chemistry here on Dylan Teacher Science. So today we're learning about fuels of hydrocarbons, or fuels and hydrocarbons, as it says here. So essentially, what is a hydrocarbon? As we discussed in the last one of organic chemistry, a hydrocarbon is an atom that contains only hydrogen and carbon atoms. So I'm going to be learning about those hydrocarbon fuels. So we have 3 different types of hydrocarbon fuel. We call these alkanes, alkenes, and alkynes. So an alkane is something like this methane here, CH4, which is this methane here. Essentially what the methane is it's a single bonded carbon to 4 hydrogens. So carbon with 4 hydrogens around it, and they're singly bonded to each other. That's all a methane is. Then we have an alkene, which is essentially this. So it's the carbon with the double bond, and then the hydrogens go around the double bond. So essentially we just go around the double bond, if you know what I mean. So then we have an alkyne, which is the same thing, but with a triple bond this time. So that's an alkyne. This would be C2H2, which I forgot the name of it. I think it would be methane, or ethine. I don't know. But anyway, next page. Our lesson. Alkane is the formulas. So this is, if you've done organic chemistry, I'm presuming yet again that you've done some form of foundation chemistry before even attempting this. So the formula for an alkane, so CH4 or C2H6, they're examples of alkanes, is the number of carbons. Carbon is the number, hydrogen is 2 times that number plus 2. That's how you calculate the number of carbons and hydrogens. N is just like X, it's a number. So for example, my carbon was 5. So then you go 2 times 5, 10, plus 2 is 12. There you go. Yeah, that's your hydrocarbon. So if this was 5, it'll be C5H12. And you got alkanes, which is a similar thing, just number of carbons and without the plus 2 at the end, so you just go 2 times that number, or let's call it X or N. And alkynes is just the same number on both sides, CnHn. So yeah. Now I've got some examples. We're going to first of all have a quick look-see at butane. Butane is a hydrocarbon. We're going to look at a different example of an alkane and an alkene. These are otherwise butane, C4H10, then we've got butene, C4H8. These are our 2 hydrocarbons. So let's say you draw a butane polymer. As we discussed, polymers are chains and monomers are singular parts that build up the chain, as discussed in the last lesson. So this is our butane. So essentially is the single bonded carbons. And we have our butene, which looks like this. This is what our butene looks like, yeah? So, yeah, that's essentially it. I am going to give you guys a few questions to leave you guys off with. I'm going to write the questions. You guys pause the video and then come back to me once you got the answers. Question 1. Question 1 is going to be this. What is the formula for hexane? What is the formula for hexane? It's going to be the first question. Okay, so I'm presuming you guys have answered that by now. You pause the video and have a look at it. So hexane, we've got the word hex. So that would mean 6, right? Hex means 6, as in a hexagon has 6 sides, yeah? Hex means 6. So, like a hexagon has 6 corners or whatever, 6 sides. So we know hex, so that means there'll be 6 carbons. And this ends with ane. So ane means alkane, ene. So hexene would be the alkene version. Hexine would be the alkyne version. So it's a hexane, which means it's an alkane. So essentially what we say is this one would be C6 comes here. 6 would go. 6 goes here. So C6H 2 times 6 plus 2. Just remember C6H2N plus 2. So N is going to be the 6 here. It's going to be our N is going to be that 6. So we go C6H10 plus 2. Sorry, H12 plus 2. It's going to be C6H14. And that is the chemical formula for hexane. C6H14, and it is a fuel. Now, the next one, you have to know foundation chemistry to be able to answer this next question. Presuming you've all watched it before, even attempting this organic chemistry stuff. So, question 2. Sorry. I have any piece of paper actually, bear with me. A lot of junk over there. Question 2 is going to be the following. Write the balanced combustion reaction. You should all know what a combustion reaction is if you've done foundation chem. If not, do it now. You shouldn't even be here, because you're going to have no idea what a chemical reaction. You don't even know what a reaction is. Don't know foundation chemistry, or watch our foundation chemistry course here on Dylan Teaches Science. So write the balanced combustion reaction of butane. And I will give you guys butane's formula. It is C4H10. Okay, so I want a balanced one. So basically, CH4 is going to have a different balance to C4H10 butane. So we should all know by now, yet again, I'm going to presume you've all watched it. I'm going to keep saying that until the silly people who watch this have not watched the foundation chem course, watch the fucking thing. Sorry for the language, but I'm pretty fed up of you watching organic chemistry and don't even know the basic chemistry. So we've got C4H10. And we all know combustion is when we add oxygen in the presence of a hydrocarbon. So that's going to be this plus this. So it's combustion, there's our reactants. And then we know that's going to produce H2O and carbon dioxide. Yep. Now all we want to do is balance this equation. So here's our equation. So we've got another way, that's CO2. Nicer. So it'll be CO2, water, which comes from our butane fuel and our oxygen. So how many oxygens do we have on this side? We've got 2, and we've got 2 on this side. Let's not worry about that. Let's actually start with the carbons. How many carbons do we have on this side? We've got 4, right? We've got 4 on this side, okay? So we're going to have 4 carbons on this side, so I'm going to put a 4, actually. I'm going to do this one in red, so you guys can actually see it. I'm going to rewrite it as this. The one on the bottom is the one we're going to rewrite it as. It's going to rewrite it as 4 CO2. Okay, so now our carbons are balanced. But now how about our hydrogens? We're going to put a 5 in front of the water. Actually, no. No, I'm just running out of room on this piece of paper, so just bear with me. I know it's a pain, usually when I film at school I have whiteboards, but they're also too small. Okay, so we've got butane and oxygen, water, and there's our reaction. Okay, so the balanced version, oh shit, hang on 1 minute, I just dropped the lid down here. Markers. Alright, now I'm going to try and keep this video just under 10 minutes, as I like to do. So, we're going to have 4 CO2, so 4 carbons. from our 2 and our butane. This is our so far balanced equation, not balanced yet. So our carbons are now balanced. Now with the hydrogens, we're going to want 5, yeah? 5 times 2 is going to give us 10. How many hydrogens? 4 times. 1 is 4 carbons. Now we go and look at our oxygens. We can tell you now they're not balanced. They've changed. So how many oxygens we got on this side? We've got 2. How many on this side? We've got 5 plus 8. 13. Yeah. Good news. We can quite easily go 13 times 2. So which is 26. Now this is where it gets hard. If we do put this here, we're going to have to put a number in front of our butane, which is going to change the carbon and hydrogen numbers. We're going to have to double these. These numbers here are going to have to get doubled. So first of all, we're going to write what times 2 gives us double of 36. So double of 36 is of course 26. So we're going to balance this equation now, which I've showed you all how to do. So we're going to need a 13 here. Now we've got 26 oxygens with only 13 on this side. So now we put a 2 in front of our butane. So we need 2 butanes plus 13 O2 atoms, or molecules more so. So now this side is balanced. This side is how it should end up. So now we're going to balance these 2 numbers here. So we're going to end up with about 10 H2O and 8 CO2. And this one at the bottom here, this one here, the very bottom, is balanced. Hooray, this one here is balanced. Okay? At the very bottom, where I put the little arrow, that one's the balanced one. So the balanced equation is 2 butane plus 13 O2 gives us 10 water and 8 carbon dioxide. That is our balanced equation. Now we're going to double check this in case I've got it wrong. So we can draw a little green line here. So now I've got this. So how many hydrogens on this side? We've got 10. How many hydrogens on this side? Oh no, sorry, we've got 20 on this side. 20 hydrogens, carbon, oxygen. Is there another one? No. So hydrogen, carbon, and oxygen. So we've got hydrogen, carbon, and oxygen. So we're at 20 hydrogens on this side. Then we have how many carbons? We've got 8. And we've got how many oxygens? 26. How many hydrogens on this side? We need to have 20. 20 tick. So hydrogens are balanced. How many carbons do we have on this side of the reaction? We've got 2 times 4 is 8. 8 on this side as well. So we're good. Now oxygens we have, let's calculate this. 13 times 2 is 26, and we have 22 on this, 26 on this side. So that is your balanced equation. The one at the bottom there, let me just get it in frame because this camera's very slow. Using a different camera today, and that is your balanced equation. Thank you for watching, guys. Hope you learned something today. Next lesson will be on carbohydrates and sugars.